Hello everybody, today we are going to solve problem number 5.34 and 5.44, and if you closely look into these circuits are one and the same, both are the same circuits. Construction wise they have made some kind of modification, otherwise both are the same. And here this V in is not marked, so you can mark it here. And here this expression or the answer is given, here the answer is not given, that's it. If you solve this 5.34, that is enough of solving this 5.4. Now let's get started. This amplifier is a non-inverting amplifier with the two inputs V1 and V2. So we know the formula for non-inverting amplifier. The output voltage is equal to input voltage multiplied by 1 plus RF by R1. And here this RF is R4, and instead of R1 you have it as R3. Otherwise I'll change it here itself. So this is your R4 and this is your R3. So what is V0? V0 is equal to 1 plus RF by R1. Instead of RF we have to put it as R4 divided by, instead of R1 it is R3 multiplied by this V in. So we need to find out what is this V in expression. Okay, so to find out this V in expression, we can apply KCL. We can mark this as input node. So what are the currents which are entering here? We can mark this as I1 current, and this can be taken as I2 current. So at input node, we have two entering currents. Okay. So sigma I in is equal to sigma I leave. So sigma I in is nothing but this I1 and this I2, that is equal to 0, no leaving currents. So how do you write this I1 in terms of V and R? That means by applying Ohm's law, I1 can be written as V1 minus this V in divided by this R1, plus I2 can be written as the potential difference V2 minus V in divided by R2, that is equal to 0. So we'll try to simplify this, and this can be taken as equation number 1. So if you take the common denominator for this R1 R2, then it is R2 times V1 minus Vn plus R1 times V2 minus Vn, that is equal to 0. Otherwise this can also be written as R2 into V1 minus Vn plus R1 into V2 minus Vn, that is equal to 0. So it is R2 V1 minus R2 Vn plus R1 V2 minus R1 Vn, that is equal to 0. So if you combine this Vn terms together, it is minus Vn, right? So it is R2 plus R1 plus R2 V1 plus R1 V2, that is equal to, or we can write this as Vn multiplied by this R2 plus R1, that is equal to R2 V1 plus R1 V2. That means Vin is equal to R2 V1 plus R1 V2 divided by R2 plus R1. So this can be taken as equation number 2. So now have a look at this first equation and the second equation. So in the first equation you can substitute the value of this second equation. That means instead of this V in, you can substitute this equation, isn't it? So this V naught is equal to 1 plus R4 divided by R3 multiplied by this Vn. Vn is R2 V1 plus R1 V2 divided by R2 plus R1. So this can be written as, if you take this as R3, there you can write this as R3 plus R4. Here R2 plus R1. There you get this as R2V1 plus R1V. Okay. So this is your V naught. So now you can refer this answer with the answer given in the problem number 5.44. So you got this answer actually, right? This is the expression given in the problem number 5.44. So I have told you that this 5.44 and 5.34 are one and the same. So now you can refer your answer. So here you have this term R3 plus R4. Here also you have this divided by R3. So you got this. Then this R1 plus R2. Here you got this. And in the numerator you got this R2 V1 plus R1 V2. So you got the same answer. So this is your V naught. Okay. Okay, thank you.